Hello, class. Let's move on to the analysis related to early exercise condition. Now, under what conditions should we exercise an American call option before option maturity? Now, you may recall that in some of the texts or earlier classes, then there was a description that the price of a American call is equal to the price of a European call because it's never really optimal to exercise the American call earlier. Now, that is only true when there's no dividend payment. When there is a dividend payment, however, there are situations where it is optimal for American call to be exercised earlier. So therefore, if a stock were to pay dividends, the price of American call is always greater or equal to the price of a European call. But if the stock were to pay no dividends, then in that situation, the price of American call will be equal to the price of a European call. Now, we are going to derive some conditions such that if the condition is satisfied, we know for sure that we will not exercise the American call, okay? But the reverse is not necessarily true because if the condition is violated, we cannot say that we will for sure it's optimal to exercise the American call. But if the condition is violated or significantly violated, then it's probably true that we should exercise the American call earlier. But it's only slightly violated, then it may not necessarily be the case that it is optimal to exercise early. Again, without dividend payment, American call options should never be exercised early, okay? Now, the condition that we calculate, I haven't tell you what the conditions are. We're going to derive them later, but the condition only applies at times immediately before the ex-dividend date. If you have a call, American call that allows you to exercise early, it is really never optimal to exercise after an ex-dividend date, because right after the ex-dividend date, the stock price dropped. So, and when you exercise, you don't get that dividend value. But whereas if you exercise before the ex-dividend date, the stock price contains that dividend payment. So if you were to have a choice, or if you are going to exercise the American call, then it's always more optimal to exercise prior to the ex-dividend date. Okay, for American put, obviously is the opposite, because the put is the stock is K, the strike price minus the stock price. So after the ex-dividend date, the stock price drops by the amount of the dividend payment. So it's always, if you were to exercise early for an American put, it's obviously more optimal to exercise that after the ex-dividend date. Again, as I mentioned earlier, violation of the condition that we're going to derive does not necessarily lead to an optimal early exercise, but significant violation will typically lead to a optimal early exercise. Okay, so let's set up the situation, the conditions here, and that allows us to do the analysis. So first of all, let's say we have a an option, an American call option. So we're at time 0 now. The maturity date of the option is T. In between the time period, there are n number of dividends that can be paid out by the stock. So, and we have T1 to Tn, and on each of the dates, there are the amount of dividend payment is D1, D2, and so on, all the way to Dn. So ST is the stock price at time T. Now here, if we have STI, for I equal to 1 to n, it is understood that it's really right before this date, the dividend DI is to be paid. Okay, just right before that. That's the convention. And the option has an expiry date of T. Now, let's first look at the condition for the last dividend payment. Now, if the dividend is exercised right before the last, if the option is exercised right before the last ex-dividend date, you exercise that, you will receive S minus K. So basically, in this case, it will be S at Tn minus K. So this is the immediate exercise value. Now, if you don't exercise, so what's the value of the option if you were to wait? Well, the option has a minimum value of S minus the dividend minus K discounted, the discounted value of K. Now, why this is the minimum value? Because if you look at the Black-Scholes formula, you can actually see that very easily, because what you really have is, S times ND1 minus K, the present value of K, times ND2. Then D2 is always is always smaller than D1 if sigma and T are greater than 0. Therefore, if D2 is smaller than D1, ND2 is always smaller than ND1. So here, you basically have assumed that D1 is equal to D2 is equal to 1, then you have this condition here, right? But you know that the S part is actually going to be multiplied by ND1, and the K part is going to be multiplied by ND2, and ND1 is greater than ND2. So that call value would necessarily be greater than this particular value here. So if you're taking this particular value here, being the minimum value, then the condition that if we do not exercise, we necessarily have the waiting value greater than the immediate exercise value. So the minimum of the waiting value must be greater than, in this case, the exercise value. Okay, and then definitely you're not going to exercise. So then if you just rearrange, you will have, if the dividend, so expressed in terms of the last dividend payment. So if the dividend payment itself is less than K times 1 minus e to the power minus r big T minus the Tn here, then we should not exercise. So this condition is equivalent to this condition here, okay? Which means the minimum value of waiting is greater than the immediate exercise value. And in such a case, you should not exercise. Now, again, because this part is only the minimum value, and so if this condition is violated a little bit, let's say the exercise value is a little greater than the minimum value. Well, are you going to exercise or not? Not necessarily going to exercise because you know your actual value of the option is greater than this. So if this blue one is just slightly greater than this red value here, it may not be actually greater than, may not be greater than the actual value of the call. So in that situation, you still not, it's optimal to exercise the call. But if this blue value is significantly greater than this red value here, then it argues that you should exercise the call option, the American call option. Now let's take a look at the condition for dividends that are paying the dividend date, ex-dividend days that are prior to the last ex-dividend date. Now, in this case, if we don't exercise, we say that the weighting value of the call is going to be higher than this particular expression here. So basically, the stock price right before the dividend payment at time t n minus 1 and minus the dividend payment here and minus the present value of the strike price where the discounting is taking place between Tn and Tn minus 1. Now you may wonder that's, I mean, you know, how come it's between Tn and Tn minus 1, but not between the final date, maturity date T to Tn minus 1? So, right, so what is a smaller discounting period here? Well, the reason for that is we can be sure the value is greater than this, but we cannot really be sure the value is greater than this blue one here if we take a larger discount period. Because the larger the discount period here, the smaller this value is, and that means the C value will be higher. So sorry, this the smaller this part, the smaller, the bigger the entire expression here. So we can be sure the stock value, that the call value is greater than this, but we cannot be sure that the call value is necessarily greater than this bigger value here. So we know that this blue value is greater than this black value here, this expression. So why? Well, the reason for that is we have dividend payment at Tn, an earlier period, right? There's a dividend there. And because of the dividend, the value of the call, this presence of the dividend at Tn lowers the value of call at Tn minus 1, because we don't know whether the call will be exercised at Tn or not. We could exercise at Tn, right? So we cannot say that the call must exist beyond Tn, because it could be exercised at Tn. Then if it gets exercised at Tn, the call doesn't last until the maturity date, okay? So therefore, we cannot be certain that the call lasts all the way until the maturity date. If we can you know, ascertain that, that means we will know the call value would be greater than this thing here, but we cannot. All we can be certain is that the call must necessarily greater than this value here, which is a smaller value. Okay, this red part is smaller than this part. Okay, so we are sure the call value is greater than this smaller value. We cannot be sure this call value is greater than this bigger value. So putting it together, we would then have when at a situation where it's not a dividend payment, the last ex-dividend payment date, then our condition is that DI is less than or equal to K times 1 minus e to the power of minus r, Ti plus 1 minus Ti. So the discounting period here is really the period from now to the next dividend payment date. So putting it together, we have two conditions. One condition is related to the dividend payment days that are not the last dividend payment. And the other condition is for the last dividend payment, the end. So here is any one less than the last dividend payment, earlier than the last dividend payment. This one is the last dividend payment here. And the difference really here is the discounting period is between the current time to the next dividend payment time. And here is the current dividend payment time to the final maturity. Okay. And as I mentioned earlier, even if the condition is violated, we're not 100% sure because we only know that the call value is greater than that minimum value, but that minimum value isn't really the value of the call itself. But if the condition is violated significantly, then chances are it's optimal to exercise much earlier than the last than at maturity.